Hello, welcome to this video on solving systems of particles problems. Okay, so in this video we'll go through how to solve the center of mass of systems of particles, angular velocity and angular momentum. Okay, alright, so if you've not subscribed to my channel yet, kindly subscribe for more videos. Okay, let's start. So we have these particles. Okay, so particle 1 giving us 2i plus 3j minus k, and it has a mass of 2k, okay, 2 kilogram. Then we have particle 2, 3i minus j, like that, okay, and the mass is also 4 kg, okay. We have particle 3 and particle 4. So the question is, we are supposed to find the center of mass, okay, position, RCM. Mind you, the first thing that you should always know is the center of mass position is actually measuring the position at which the center or the mass will be centered at, okay, for equilibrium to be obtained, okay. Alright, so given a system of particles like this, we say that the center of mass position, RCM, okay, is equal to x bar, y bar, z bar, okay, since we are dealing with a three-dimensional space, okay. Now with this, we said that our x bar is equal to summation of the mi's, okay, let me write it for you, summation of the mi's times xi, okay, all over summation m, which is the total mass, okay, where the I will be 1, 2, 3 and the rest, okay. So here what you do is it just comes to your R1, okay. So in R1, what is our x1? Our x1 is what? The component of the I, this component, okay, and that is what? 2. Our x2 is what? Here is 3, okay. Our x3 is also what? 1. I'm just writing the components of the i's, okay. Now x4 is what? -1, okay. So what this summation means is that when you pick any of the x's, okay, you multiply by the mass allocated to it, okay, then divide by the total mass. Now if you are to calculate for the total mass, it means you're supposed to add all the masses. So 2 plus 4 plus 3, which will give us 9, plus 3.4 kilograms, which will give us what? 12.4 kilograms, okay. So the total mass is 12.4 kilograms. I hope you can see that, because I have 2 kilograms, 4 kilograms, 3 kilograms and 3.4. When I add all, I get 12.4 kilograms, okay. Now if I pick x1, which is 2, I multiply by the located mass, which is 2 kilograms, then plus, this is how you do it, okay. Then I pick the 3, x2, sorry, I multiply by the mass 2, okay, plus I pick x1, multiply by mass, sorry, x3 multiply by mass 3, okay, plus x3, which is -1, so it will be a negative, okay. So minus 1 times x4, which is 3.4, sorry, our mass 4, okay. Now you can use my calculator and point it straight, okay. Alright, so 2 times 2 plus 3 times 4 plus 1 times 3 minus 1 times 3.4, and the answer is 15.6, okay. So our x bar is equal to 15.6 over 12.4, okay, and this will give us what? Divided by 12.4, we are getting 15.6 divided by 12.4, so we are getting 1.2581, let's say to 4 decimal places, okay. So this is what we have for our x bar, okay. We can write x bar somewhere, okay. Alright, so I'm erasing x bar, okay. So we are saying that x bar is what? 1.2581, okay, in 4 dp. Okay, all right. So x bar is equal to 1.258, let me say in 3 dp. This is how you write it, okay. And our next task is to find our y bar, okay, because we wrote something like y bar, x bar, and z bar, okay. Y bar is also equal to summation mi yi over total mass, okay, and this is equal to mi. So for the first mass 2 kilogram, what is the associated y component? That is what the component on the j, which is 3, okay. So I get 3 plus, sorry, okay, plus then 4 times the component on the j for the second particle is what, -1, plus 3 times the component of the third one is 3, okay. I'm just writing the component of j's, okay. That will be for the yi's. Then plus 3.4 times 2, okay, all over the total mass is 12.4, okay. So this will give me what, 2 times 3 plus 4 times -1 plus 3 times 3 plus 3.4 times 2, and this is giving me 17.8 for the numerator, and the denominator is 12.4, okay. This means that my YCM is 17.8 divided by 12.4, and that is equal to, y bar is equal to 1.435, okay, in 3 decimal places. Alright, so it's left with what, our z bar, okay. So let's quickly do that and come and put our answers in the general solution, okay. Now our z bar is also equal to summation mi, okay, zi's over the total mass, okay. This means z bar is equal to summation mi. So I pick the first mass 2. What is the z component in the first particle? Is what, -1, okay, the component here, okay, plus when I pick the second mass, which is 4, times the second component for the z part is what, 2, plus when I pick the third mass, 3, multiplied by the third component for the z bar in the third particle is 1, okay, and plus 3.4, okay. Let me write it for you. 3.4, okay, times -3. Wow. -3 and all divided by 12.4, okay. So z bar will be equal to, alright, so that one to 2 times -1 plus 4 times 2 plus 3 times 1 plus 3.4 times -3, and the answer is -1.2 for the numerator, then over 12.4, okay, and this is equal to -0.097 to 3 decimal place, okay. So my z bar is also equal to -0.097 7. Alright, so these are my x bar, my z bar, and y bars. Okay, so what will be my final answer? If you remember, I first said that our RCM, or center of mass, is equal to x bar, comma y bar, comma z bar. Okay, so for this system of particles, our center of mass position is equal to x bar is 1.58, sorry, 1.258 rather, 258, okay, comma 1.435, okay, comma negative 0.09 something. Okay, let me erase it and write it for you to see better. Okay, so this will RCM will actually give us our x bar is what, 1.258, comma our y bar is 1.435, and our z bar is what, negative 0.097. Okay, so this is it for this question. I hope you understood it. Okay, alright, so let's move on to the next question. Now, find the mass of a wire of length 10 meters and density lambda equals this. Okay, and the length is what, 10 meters. Now, if you remember, in our previous videos, we said something like the density of any substance is actually equal to dm, okay, over some dA or dV. For a particular wire, we said since it is just 1d, the density is given as what, dm over dx. Okay, alright, so where x will run from 0 to the total length. Okay, here the total length L is given as what, 10 meters. Okay, and lambda is given to us, which is what, 2s squared minus x. So it means my dm is equal to lambda dx. Okay, so my mass will be equal to integral of lambda dx. Now my mass is m, I don't know, my lambda is given to be 2s squared minus x, and we said the integral will run from what, 0 to the total length, since it is just a 1d. Okay, so my mass is equal to integral from 0 to 10, then 2s squared minus x, okay, dx. Alright, so this is simply equal to 2 over 3 s cube, okay, sorry, s cube, and minus 1 over 2 s squared. Okay, all running from where, 0 to 10. Okay, so the mass is just calculating this. Okay, so it's 2 over 3 times 1000, because when I put 10 in place of x, I'll get 10 which is 1000. Okay, I get 2 over 3 times 1000, or in other words, I can still write it as 2000, okay, over 3 minus half of 10 squared, and half of 10 squared is half of 100, which is 50. Okay, so 2000 divided by 3 minus 50, and my answer is equal to, in fraction is 1850. Okay, 1850 over 3, and in decimal is 616.67 kilograms in 2 decimal place. So this is simply the solution to this question. Okay, it's very simple, right? Alright, so let's move on. Now, a copper wire of length of density lambda equals 1/3 s cubed minus 2x of length 30 centimeters. Find the center of mass of this wire. Okay, if you remember, we said just in the last example that we went through, we said that the density is always equal to, since we are dealing with a copper wire of some length, okay, it is a 1d, okay, it's always equal to some dm over dx. Okay, now we said the center of mass would just be in just the x direction, okay? So it will be just xcm, okay? And this xcm, in our previous videos, we say the xcm is actually equal to integral of x, okay, dm, okay, over integral of what, dm. This is what happens, okay? But now if I'm to rearrange the first one I wrote, it means the m is what, equal to lambda dx, okay? I hope you get it. So this whole thing will be equal to integral of what, x lambda, okay, dx over integral of what, lambda dx. Now if lambda is given as a constant, then lambda at the numerator can cancel lambda at the denominator. But if it is not a constant and is given in the question like this one, okay, then you need to perform your integration on it. Alright, I hope you get it. So simply our SCM, okay, will be equal to the integral. Then what will be the limit? We always say that in one dimension the limit will be from 0 to the total length, okay? But the total length here is what, 30 centimeters, and 30 centimeters is the same as 30 times the centi is 10 to the negative 2, okay? Alright, let me write it well for you, okay? The 30 centimeters, I have to convert it to meters before it can work, okay? So 30 centimeters is actually equal to 30 times 10 to the negative 2 meters, okay, which is 0.3, okay? So the length will run from 0 to 0.3, but I'm coming to erase some parts and then write it well for you, okay? Alright, so like I said, I need to write it simpler so that we be able to solve it quicker and go, okay? So this is integral of x lambda dx, okay, over integral of what, lambda dx. And you are saying this will be the definite integral 0 to what, definite integral 0 to 0.3, okay? Alright, 0 to 0.3, forgive me, okay? Then x into lambda is what, 1/3 s squared, okay, 1/3 s squared minus 2x, okay, dx over integral of lambda, okay, so 1/3 s squared minus 2x all dx, okay? Mind you, s is running from 0 to 0.3, okay? So that is also the limit for the down one, okay? Now you can point this on your calculator straight, but you can go through a whole process if you want, okay? I'm actually pointing this on a calculator straight for you because I believe we can do simple integration by now, okay? The integration demands a whole lot of calculations or a whole lot of simplifications I would go through, but this is very simple like that, okay? So I can point the top one on the calculator with the limit, everything inserted in it, and I'm getting the top to be xcm is equal to negative 0.017325 for the top one, okay? Let me erase it and write it well for you. Alright, so xcm, like I said, xcm is equal to the top numerator is giving me negative 0 point, provided I point everything, I've pointed everything correct, okay? So negative 0.01, then to 3 decimal places 7, okay, over, then I punch the down parts, okay, in a calculator like that, same process, and that one too gave me negative 0.01, 0.087. Okay, so if you go through the process in a nicer way, this is what you're supposed to get, and our XCM will be equal to negative 0.017 divided by what we had, and that is 0.195 something. Okay, 0.195 in 3 decimal place. Okay, I hope you can see that. Okay, so but the unit should be in meters. Okay, since we're dealing with meters, so this is the center of mass position for this copper wire. Okay, with the given dimensions. All right, so let's go to the next question. Okay, I find the mass of a rectangular surface of size 10 meters and 12 meters with density lambda equals x squared plus y cubed minus xy. Okay, so with this we have to recall some formula. Okay, we said that in a 2D, lambda is equal to dm over dA, where dA is what? Dx times dy. Okay, this is what we said. So we said that our dm is actually equal to lambda dx dy. Okay, the question is find the mass of the rectangular surface. So here, from just this formula, okay, from this one, okay, I can see that my m is equal to integral of lambda dx dy. Okay, and my y will be what? My x will be what? Now I've been given two lengths. Now the size of the rectangular surface is 10 meters and 12 meters. I would always advise you set your x to be the smaller one and your y to be the longer one. Okay, now with this, it means the mass will be equal to the double integral, since we are dealing with 2 dimensions. Okay, then 0 to what? 12, 0 to what? 10. Then my lambda is given as s squared, okay, plus y cubed. Okay, let me write the cube well. Y cubed minus xy. Okay, then the x dy. Okay, now with this, if I do the first integral properly, 0 to 12, and I'm supposed to get something like this. I integrate everything with respect to x. I'm getting 1 over 3 s cubed, okay, plus xy cubed, okay, minus 1 over 2 s squared y from 0 to 10 dy. Okay, now this whole simplification will give me 0 to 12, integral from 0 to 12. Then when I put my limit in, 10 cube will be 1000. Okay, 1000 over 3 plus 10y cube, okay, minus 10 squared is 100, and half of it is what? 50. So minus 50y or dy. Okay, now when you are in 1D like this, you can point it on a calculator, or you can still go through it by step by step, like if you want. Okay, but for time sake, let's try to do this on a calculator, but if you go through step by step, you'll be able to get it. Okay, so I point my 1000 over 3 plus 10, then y cube, okay, and minus 50y. Okay, that is all right. So we'll get something like the mass will be equal to 52,240 kilograms. Okay, so this is very simple. So if you went through the simplification of this side, okay, the integral of that side, step by step, you are supposed to get 52,240 kilograms. Okay, that is the mass that you get for this rectangular surface. Okay, all right, now let's move on to the next question. All right, find the mass of a cuboid of density lambda equals that, and x equals this, y equals that, and z equals that. Okay, so here I believe you can do it. Now we are saying that lambda is always equal to the m, okay, over some dA, but since we are dealing with a cuboid, we can't use the v. Okay, and this implies that my dm is equal to lambda dv. So m will be equal to integral of what? Lambda dv, and m is equal to integral, this one, since we are dealing with the 3 dimensions, so it becomes a 3-pole integral. Then lambda is what? You put your lambda there back, then dx dy dz. Okay, so my m is actually equal to, now z is from where? 0 to 8, y is from 0 to what? 5, my x is from 0 to 4, then my lambda is what? S squared yz plus 2xy plus 3z. Okay, dx dy dz. Okay, so if you do everything properly, it's from 0 to 8, from 0 to 5. Okay, now with respect to x, we get 1/3 s cube here, the first 1yz plus s squared y, okay, plus 3xz from 0 to 4. Let me write it all for you. 0 to 4 dy dz. Okay, now let's simplify this and write it at the top here. Okay, so I hope you can simplify this. Alright, so if I put my things in, okay, I'll get my mass to be equal to integral from 0 to 8, from 0 to 5 again. I'm putting 4 and 0 in, I'll get something like 4 cube, and 4 cube is what? 64, right? Okay, so I get 64 over 3 yz, okay, plus 4 square, which is 16y, plus 3 what times 4, which is 12z, then dy dz. Okay, so now with this, let's integrate everything with respect to y again, and then from there we can punch everything on the calculator and go. The mass is equal to integral from 0 to 8. With respect to y, we'll get something like this: 1/2, okay, times 64 over 3, okay, then y squared z plus 16/2 is what? 8y squared plus 12y z dz. Okay, now it's from what? 0 to 5. Okay, so the mass is equal to integral from 0 to 8. Now if I put everything in, okay, this 2 can go here 1 and goes here what? 32. Okay, so we can actually have that. And the y squared, putting everything in, when I put 5 in place of y squared, I'll get 25. Okay, 25 times 32, that will give me 800. Okay, then over 3 z plus 8 times 5 squared, which is 25, that is 200. Okay, plus 12 times 5, okay, which is 60 z then everything now has reduced to what? dz. So you can point this on a calculator straight and write something like the fraction 800 over 3, then z, okay, plus 200 plus 60 z, okay, the limit is running from what? 0 to 8, okay. So the mass here is equal to 36160 over 3, okay, which is equal to 12053.33 kilograms, okay. So this is the mass, okay. Remember, it's a point, so it's 12,053.33 kg, okay. It's 12,053.33 kg of mass, okay. So that is it for this particular question. I hope you understood it. Alright, I just point this on a calculator because of time factor, but you can also go through the integral of the z aspect, okay. Alright, so let's move on. Now find the mass of a cylinder with the following dimensions, okay. So the dimensions are given as this, okay. You are supposed to find the mass of this, okay. And we know mass is always equal to, using our formula, we are saying that it's always equal to integral of lambda dA, okay. And this, you can see there are some angles and some rows and a whole lot, okay. So in a cylinder, the rho here is the same as a radius in the circle, okay. It's actually a radius, okay, but here we are using a rho, okay. And there is this file, and the file is the same as the theta, okay. And here there is a sigma here. The sigma here is the density, okay. So now there is a z here again. This z is as a result of what's the cylinder being a 3D. Then it means that our dA is supposed to be what? A dV, okay. So the mass is actually equal to 3 full integrals, okay. Then lambda dV is what? Dx dy dz, okay. Now I'm coming to change everything here to a polar coordinate, okay, in terms of cylinder. So in terms of a cylinder, one thing you should notice is that dx dy, okay, ds dy, okay, dz is actually equal to rho d theta, or d phi. Let me use phi because there's a phi here. D phi dz, okay. So this is what you should use. It's rho d phi dz for a cylinder, okay. So now we are good to go. We've been given the limit of rho, the limit of phi, and the limit of z, okay, and know our lambda. So quickly let's put everything in place of the mass and go, okay. Try to remember this formula. I'm coming to quote it again, okay, but this time I'll put everything in, okay. So let's start with our mass and say that our mass m is equal to, now the last one is z, so I'll move from z is what? 0 to 6, okay. The integral, the next one is phi. Phi is what? 0 to 2 pi, okay. And the next one is rho. Rho is 0 to what? 5. Everything was given in the question. This is rho, this is phi, and this is what? Z, okay. So now with this, our lambda is what? Oh, sorry, I used lambda previously because I've been using lambda for the density. Here the density is in terms of sigma, okay. So it's 2 rho phi squared plus z cos phi, then the s dy dz is what? Rho d rho, okay, d phi dz. I hope you get it now. So our mass will be equal to, from 0 to 6, now from 0 to 2 pi, then from 0 to what, 5. I can multiply through by rho, okay, and I'll get 2 rho squared 5 squared plus 0 cos phi, the rho, the phi, the z. So now let's integrate with respect to rho, okay, from 0 to 6, from 0 to 2 pi, okay. Now in terms of rho, if I integrate this side with respect to rho, I'll get 2 over 3 rho cube 5 squared, okay, plus integrating this side with respect to rho, 1 over 2 z rho squared, because there's a rho here, then cos phi. So from the phi, the z. So we have been able to do it for rho. Rho is from 0 to what, 5, okay. So let's simplify it and put it back in our mass problem, okay. So if you can start putting it back in your own calculator and see what you will get, okay. Now if I put it back, okay, if I put it back, I'll get something like this. Mass is equal to integral from 0 to 6, integral from 0 to 2 pi, okay. Then putting 5 in place of rho, wherever I see rho, I'll get 5 cube, which is 125, okay. 5 cube 125, okay, times 2 over 3. So let's do it quickly, and we have 250 over 3, okay, 250 over 3 rho squared, sorry, 5 squared, then plus half of 5 squared, okay. So 5 squared is 25, so we get 25 over 2, then z cos phi, okay. We are done because you just have two terms, okay. Alright, so I have this, then the phi, sorry, yeah, the phi, the z. Okay, so let's try to simplify the next one with respect to what, phi. Okay, so mass is equal to integral from 0 to 6. Then with respect to phi, when we integrate this side, we get something like, since this is a squared, we get 1 over 3 phi cube, okay, and multiplying that, we get something like this. We get 250 over 9, because it will come 1 over 3 will come and multiply the 250 over 3, and that will give us this. Then phi cube plus 25 over 2z, okay. Then the reason why it is plus, I hope you know it, okay, over 2, then sine of phi, you go and integrate cos, you get sine, okay. Then this is from 0 to what, 2 pi dz, okay. So m is equal to integral from 0 to 6. Now if I put 0 and 2 pi, automatically, you know, if I put 0 in, everything will give me 0. Sine 0 is 0, okay. So 2 pi, when I put 2 pi in place of phi cube, I'll get 8 pi cube, okay. 8 pi cube, so it's 250 times 2 pi all cube all over 9, and 2 pi all cube will give me 8 pi cube, okay. So 250 times 8 all divided by 9, and that is 2000 over 9, then pi cube, okay, plus 25 over 25 over 2 z, then sine of phi. Sine of 2 pi. Okay, sine of 2 pi is what? 0. Okay, this is what you should know. Sine of 2 pi is 0. Okay, so everything now reduces to integral from 0 to 6. Okay, 2000, okay, over 9 pi cube dz, because here our sine of 2 pi is 0, so the z part will go, so pi cube and dz. So now with this, let's erase the top here quickly and simplify our mass and put it back. Okay, now mind you, if you are doing, just maintain everything in terms of pi, because you've not been given pi, so after everything you should maintain in pi. Mass is now equal to what? The integral of the whole of this, and we'll get 2000 over 9 pi cube z, okay, from 0 to 6. Now if I put 6 in, it becomes 6 times that. Okay, so it becomes 6 times 2000 over 9 times pi cube, and that will give me 4000 over 3 pi cube. And this is your final answer for the mass of the cylinder having these dimensions. Okay, alright, so let's move to the next one. A 5 kg mass is placed at the origin, and a 9 kg mass is also placed at place x equals 2 meters. Where is the center of mass? Okay, so let's try to draw a quotation plane and see. This is the origin, okay, and this is my x coordinate, this is my y coordinate. Now we are saying that a 5 kilogram mass is placed at the origin, so here at this point there's a certain 5 kilogram mass here, and a 9 kilogram mass is placed at a point x equals 2. Let's say if s is 2 meters here. Okay, I hope you know why I'm putting it here, because when you say s equals 2 meters, it means that when you move 2 meters on the x axis, this is the value. Okay, so there's a 9, s equals 2 meters, there's a 9 kilogram mass here. Where is the center of mass? If you remember, I said in the beginning of the video that the center of mass is actually measuring a distance or a position. Okay, so at what point here is our center of mass located? Okay, alright, so that's the question you should be asking yourself. Now we know that the center of mass is given as what? Okay, so at the origin, what is the coordinate for the origin? The coordinate at the origin here is what? 0, 0. Okay, and the coordinate at the point s equals 2 meters is what? 2, 0. Now what is my x1? My x1 from the origin is what? 0. My x2 at the point s equals 2 meters is what? 2. Now at x1, my mass 1 is equal to what? 0. Is it 0? No, it's 5 kilogram rather, 5 kg. And at a s2, my mass 2 is equal to what? 9 kilograms. Okay, here it becomes very simple as that, and now we write our center of mass to be equal to x bar. Okay, because we don't have any y coordinate, this is equal to summation of, if you remember in the first video, s component times the first mass. Okay, the first s component was 0 times the first mass, and that is 5, plus then plus the second s component is 2 times the 9 over the total mass, which is 5 plus 9, and this is equal to what? 2 times 9, which is 18, over 5 plus 9, which is what? 14. Right, and this is equal to 2 times 9, that is 18 over 14. I'm putting it on my calculator, so we get 7 over 9, which is 1.28, let's say 6 meters on the x-axis. Okay, so this is this relation for this particular question. Okay, I hope you understand it. Alright, so let's go to the next one. Now, an 8 kilogram mass is placed at x equals 3 meters. Okay, where should a 10 kilogram mass be placed along the x-axis so that the center of mass is located at x equals 4.5? Okay, so here, this with the help of the Cartesian plane. So if I have this, okay, and I have this being my Cartesian plane, okay, this is my x-axis, this is my y-axis. Okay, now with this, you're saying that when you move on the x-axis 3 meters, let's say here is 3 meters, I don't know, but let's say here is 3 meters, we have a mass located at here, m1, and it's equal to, okay, the mass here at this point is what, 8 kilograms. Okay, and now where should the 10 kilogram mass, we don't know, be placed such a way that the center of mass, let's say I'm imagining, or let's say the 10 kilogram mass should be here. Since this 4.5 is bigger than the 3 meters, it means center of mass is far from the 3 meters. So it means that the center of mass is somewhere here. Okay, when you place the 10 kilogram mass at a point somewhere here, so at this point you don't know, so let's call it x, and then the mass here is what, 10 kilogram, but the center of mass is located somewhere here, which is what, 4.5. So what is the value of this x? This is very simple, right? Because I will just write a coordinate at this point. At the point where x equals 2 meters, I have the coordinate what, is rather 3 meters. Okay, at this point I have the coordinates, the point where x equals 3 meters, I have the coordinates what, 3, 0, and the mass is what, m1 is equal to what, 8 kilograms. Now at this point where x equals x meters, we don't know. Okay, x equals x meters, the coordinate is x0, and that is what we want to find. Then the mass 2 is given as what, 10 kilograms, but we know the center of mass already, okay, to be 4.5, but we know the center of mass is actually equal to the product of this x1 and its mass, that is 3 times 8, plus product of this x and its mass, so it becomes 10x, okay, all over the total mass, which is 18, that is 10 plus this. That will be the formula for the center of mass. Okay, but the center of mass is given, so all that we can do is that we write the center of mass, which is 4.5, to be equal to, now 3 times 8 is what, 3 times 8 is 24, okay, then plus 10x all over 18. Okay, so now let me write it down here. 18 times 4.5, you just do cross multiplication, so 4.5 times 18, and we get 81, which is equal to 24 plus 10x. So here everything becomes simple. 81 minus 24, that give me 57. Okay, let me change it small. So 57 is equal to 10x. So quickly, x is equal to what, 5.7, okay, meters. Alright, so the question is, where should a 10 kilogram mass be placed? The answer is it should be placed at the point x equals 5.7 meters. I hope you get it. Okay, so this is a solution to this question. This is very, very simple. Okay, so let's go to the next one. A 10 meter long 4,000 kilogram truck has a center of mass 4 meters behind its front. Where should a 1,400 kilogram mass be placed so that the center of mass will be right at the middle of the truck? Okay, alright, let's go ahead and solve this question. Okay, now the length of the truck is given as what, 10 meters, and the center of mass at that point where no other external mass has been added is 4,000 kilograms. So let's analyze that first condition and see. So let's say if this is the track, okay, if let's say this is a track, okay, let's say this is a track, okay, and the length is the length of the track, 10 meters, okay. And now we are saying that the mass is what, 4,000 kilograms at the beginning, and the center of mass, that's the position of the mass. This means that at the first condition where the mass was 4,000 kilograms, no other mass was added. So it means the center of mass was actually the place that we put the first mass, because we didn't have any other mass, and so the center of mass was placed at what, 4 meters, meaning the mass, the total mass is located at 4 meters. So it means the 4,000 kilogram was here. This is because I said that center of mass position is simply calculating the point where the mass to total mass of the system will be at equilibrium. So this is the first condition that was given. And the question is, where should a 1,400 kg mass be placed? So the center of mass will be what, 5 meters. Okay, so now at first the center of mass was 4 meters. So the center of mass now is what, 5 meters here. When we included a new external mass, okay, so let's say we included it somewhere here that we don't know. Let's call that length L, okay, and we included it at 4,000, the mass to be what, 1,400 kilograms. Okay, so where should we place it so that the new center of mass will be 5 meters? So in the first place, we didn't put any other mass on the track. The mass of the track was just 4,000 kilograms, and the center of mass was something. It means that at that point, that was where the mass was at equilibrium. So you just put it like that. Now we come and put another mass on the track. Where should we put it so that the new center of mass will be 5 meters? So this is where, in the second condition, it becomes systems of particles, because the first one was just one condition and that was all. Now in the second condition, you have two. So let's say if this is on the x-axis, okay, I'm doing it in the horizontal way, you can do it on the vertical way. If this is supposed to be the x-axis, and let's say here is, let's say, the origin, okay, here is the origin, then at this point, okay, I have the coordinates at the point where the mass is equal to 4,000 kilograms, okay, I have the coordinates 4, 0, and at the point where the mass is equal to 1,400 kilograms, I have the coordinate L, 0. Okay, but the center of mass cm is given as 5 meters. Okay, this becomes very simpler because you know how to do center of mass. So let's erase the diagram and then continue with our solution. Okay, so we know that the total length is what, 10 meters, and let's start with the solution. Okay, so now the center of mass, which is 5 meters, is equal to the first mass, okay, in the first condition, that is 4,000 kilogram times the first x coordinate plus the second mass, 1,400 times the second x coordinate over 4,000 kilogram plus 1,400. Sorry. Now, with this conditions given, or with this equation set, let's try to analyze something. So 5 into, when you add the denominator, what will you get? 4,000 plus 1,400. I'm supposed to get 5,400. Okay, then it's equal to 4,000 times 4, and that is 1,600, no, 16,000 rather, okay, plus 1,400 L. Okay, so now 5 times 5,400 minus 16,000, okay, and that is given as 11,000 equals 1,400 L. Now L is equal to this 11,000 divided by 1,400, and the answer is 7.8, let's say 6 in 2 decimal place meters. So let's go back to the question. You're saying that a 10 meter long this, so where should a 1,400 kilogram, this one, mass be placed so that the center of mass be right at the middle of the track? Okay, that was the reason why we said the new center of mass is 5 meters, because the total length was 10 meters and then at the middle it becomes 5. Okay, so now based on our calculation it should be placed at where 7.86 meters. Okay, so that is it for the solution to the question. Okay, now we have another question. A bicycle wheel of radius 0.25 meters rolls down a hill without slipping. Its linear velocity increases constantly from 0 to 7 meters per second in, so the radius is what, let's try to fish out the variables given, and then the velocity is given from 0 to what, it increases from 0 to 7 meters per second and in times 3.4 seconds. So the angular acceleration you are supposed to find, the angular velocity you are supposed to find. Now there is a formula you should know. The angular velocity is known as omega and it's always given as v over r, or you can write the linear velocity in terms of angular velocity. The linear velocity is equal to omega r, where this omega is angular velocity. So always the angular velocity is equal to what, v over r. Okay, now if you know acceleration is always equal to, let's say linear acceleration is equal to v over time. Okay, so it means that the angular acceleration, which is alpha, is also equal to omega over time. Okay, where the time is given as what, 3.4 seconds. So it means we are supposed to solve for b before we can solve for a. Okay, or we can solve for angular velocity, and then when you use it to solve for a, come to b and you just state it like that. Okay, so let's go ahead and do it. So with the angular velocity, yeah, this is the formula I said, and this is the angular acceleration. Now with the angular velocity, v will be equal to omega is what, I don't know. So we know that velocity increased from 0 to 7 meters per second, so it means the total velocity is equal to what, 7 meters per second. Now it means my omega will be equal to v, which is 7 meters per second, over the r, which is 0.25. okay, and this is equal to 7 divided by 0.25, the same as 28. Okay, so it's 28, and then the units for angular velocity is radians per second, rad per second. Okay, now the angular acceleration, this is equal to omega over time, and the time is 3.4, so omega is 28 over time 3.4 seconds, and this is equal to 8.24 radians per second squared. Okay, this is very simple, very simple like that. Okay, so that is it for the solution of this. Let's continue with our next question. And now we are saying that the position and the angular velocity of a particle is given by that r of t equals 2ti plus that, and omega of t is given by that. The mass of the particle is 2 kilograms. Okay, so I hope you are settling, so you are trying to figure out some of the things. So we need to have this, we need to know this as well, and the mass is what, 2 kilograms. So that's how you solve physics questions. You just try to figure out the terms or the things given. Okay, so you are supposed to calculate the angular momentum at the time t equals 1, the torque at the time t equals 1 seconds, and the kinetic energy at time t equals 1 second. Okay, so let's go ahead and then write what we have. Okay, so we have these. We have this, and the mass, sorry, you didn't write the mass. The mass is equal to 2 kilogram. Okay, and this is the formula that we use to write, we use to find the angular momentum. Okay, this one. Okay, so the formula is L is equal to mr squared omega. Okay, now you're supposed to find the angular momentum at time t equals 1 seconds. Okay, so once we know the time, we can simply evaluate the r at time t equals 1 and omega at time t equals, and multiply them straight, because if you have to find r squared in terms of t and omega, then we'll be dying. We will be dying a lot. Like, I won't lie. Okay, so let's try to evaluate r at 1. R of 1 second is equal to 2i plus 3 times 1 plus 2, which is 5, j plus k. This means r of 1 squared, because you are doing everything at r to at 1. It means r dot r, so the dot product of two vectors, so 2 times 2 plus 5 times 5 plus 1 times 1, and this will give me 4 plus 25, okay, plus 1. I hope it is correct. Now this will give me 30. Okay, now omega at 1 is equal to I, because if I put 1 in place of t cube, I'll get 1, so minus 4j plus 2k. Now the mass is also given as what, 2 kilograms, so it means my angular momentum will be equal to the mass, which is 2 times the r square. R squared is 30, so 2 times 30 is what, 60, then multiply by the whole of this, so you get 60i, okay, minus 60 times 4, okay, and that will be 240j, then plus 2 times 60, 120k. Okay, this is the answer for your angular momentum. Okay, this is very simple, right? Okay, so we are supposed to calculate the angular momentum. Let's go and check the question again. Alright, so calculate the angular momentum at time t equals 1 second. So because of that, it means we are done with this first question. Let's go to the torque. The torque is some way. I hope you can see the answer, so keep this answer. Okay, alright, now let's erase everything and try to do for the torque. The torque, because of the torque, we need to evaluate the angular momentum at time t equals t before you can find the torque, because the torque is actually the derivative of this angular momentum with respect to time. Okay, so you are saying that the angular momentum is equal to mass, which is 2 kilograms, times this dot itself. Okay, so r dot itself is just the I component times itself, which will give me 4t squared, plus the distinct component will give me 3t squared plus 2 squared. Okay, squared, then plus t to the power 4. Okay, I hope you can see that, because the k component is t squared, so when I square it, I multiply by itself, become t to the power 4, then times, okay, let me use the dots, because dots, then wow, let me go and check. I wrote something here. Okay, please look at this. The v omega, so the vt is not vt, it's omega t, sorry. Then times, okay, let me use the times like that, omega t, and omega is what? T cube, okay, I minus 4tj plus 2k. Okay, so someone will say, why didn't we evaluate this before? Because this will make our work a big tiresome. But then I would have a way to do this. Okay, so don't worry. You can see that this is a product of two variables. Okay, the whole of this, okay, multiply by the whole of this. Okay, the two, we are not interested in it because it's just a constant. Okay, so it means the L dt, if you want, you can go ahead, take your time and expand everything before you can differentiate. But then I'll differentiate straight away because I actually have a way of doing this. So it's just 2. Then you first differentiate the first part. The first part is the whole of this because it's just multiplying everything. Then if I differentiate the whole of that bracket, I'm differentiating 4t squared with respect to t, and I'll get 8t plus, and differentiate this bracket, okay, is 2 times the differential of that bracket, and that will give me what? 6t, okay, into 3t squared plus 2. Then I'll subtract 1 from it and I'll get just like that. Then plus 4t cube, okay. Then I keep this part, okay, the omega part, so I'll keep t cube, okay, I minus 4t j plus 2k. Then plus, I'll this time keep the 2 times 4t squared, okay, plus 3t squared plus 2 all squared plus t to the power 4. I keep it like that. Now I differentiate this part, okay, and that'll give me what? 3t squared I, well, let's try to write everything clearly. 3t squared I minus 4j plus 0. Okay, so let me no, I shouldn't write a 0. 4j like that. So this is a derivative. This is very simple, okay, and this is equal to what? Our torque. Now with this, let's evaluate everything at time t equals 1 second. Since we're given time t equals 1 second, you can do it very simple like that and go. You need not to simplify it before you can do it, okay? Alright, so let's erase the top here. This is the derivatives. If only we did the derivative right, this is what you're supposed to get, okay? Now our torque will be equal to putting everything back, and the torque will be equal to, now I have 2 into, I have to put time equals 1 second in all of these expressions, okay? So if I put it at the place 80, it becomes 8 times 1, okay? So I get 8 plus then 2 times 6 times 1, and that will be what? 12. We got 2 times 6 is 12 into 3 times t squared. 1 square is what? 1. So 3 times 1 plus 2, that is what? 5, okay, plus 4. We got 4t cubed is what we have. Then times, putting 1 in this, that is in this side, okay. Alright, I hope you can see that. When I put 1, I'll get I minus 4j plus 2k. Right, this is very simple. Then there is a plus here, mind you. So plus 2, then putting 1 in that, I'll get 4 plus 3 plus 5, sorry, 3 plus 2 is what? Because if I put 1 here, I'll get 3 plus 2 is what? 5, and there's a square, so 25. Okay, plus 1, like that. Okay, then multiplying this, I hope you get it. So it becomes 3i minus 4j, like that. So after putting 1 in, this is what you have for the torque. And with this, I believe our simplification is becoming simpler and simpler and simpler, because it has been reduced from the huge variables to this. So torque is equal to 2 into, now if I have 8 plus 12 times 5 plus 4, and that will give me 72. Okay, then I minus 4j plus 2k, or plus 2 into 4 plus 25 plus 1, 30 into 3i minus 4j. Okay, now I get torque is equal to 2 times 72 is what? 144. Then multiplying the whole of this bracket, so 144 I minus 144 times 4, that becomes 576 j, plus 144 times 2, and that will give me 288 k. Then plus 2 times 3 is what? 30 is what? 60. Then multiply this one, so 30 times 2 is 60, then times 3, you get 180. Sorry, you get 180, right? 180 I minus 4 times 60, so 4 times 60, 240 j. Okay, so everything is becoming very easier. Now you just have to add I to I's, J's to J's, and K's to K's if only we have some. Okay, so our torque will be equal to, now 144i plus 180i, 144 plus 180, and it's 324i, and we have minus the j, have 576 minus 576 minus 240, we have 816j. Then there's no other k component at this side, so I have 288k. So this will be for the torque of this particle. Okay, I hope you get it. So it's very easy like that. So let's go ahead and do the last one, and the last one is what? The kinetic energy of the particle. Okay, now with the kinetic energy of the particle, always know that you can sometimes use what you know to find what you don't know. Okay, you know the kinetic energy of a linear particle is what? Half mv squared. Okay, now in angular particle, v is equal to v is equal to what? Omega r. So I can set v equals omega r in place of this, and I get half omega r squared. Sorry, omega r all squared. Okay, and this will give us half omega squared r squared. Okay, this is very simple. Okay, so, and with this we are also calculating the kinetic energy at time t equals what? 1 second. So half m omega squared r squared. Let's come and write it back, and insert our time straight, omega squared r squared. Now at time t equals 1, omega squared will be equal to what? I minus 4j plus 2k this squared. Okay, so it's like it dot itself, and that will give me 1 plus -4 times -4, that will be 16, plus 2 times 2, which is 4, and we'll get something like what, 16 plus 4 plus 1, and that is 21. Okay, then r squared will be what, we did it and we had 30. Okay, but we can go through it again, and that will be 2i plus 5j. I'm evaluating them at time t equals 1, so this is at time t equals 1 seconds. That's why we are doing this. If not, and time wasn't given, then we are supposed to find r squared omega squared in terms of t. Okay, but since the time is given, we can do that quickly. And we had this to be 2 squared, which is 4, plus 25 plus 1, which is what, 30. Okay, so this is very simple. Now we have 21 and 30, so let's come back and write them here, and we get our answer very quickly like that. So I have my kinetic energy to be equal to half times the mass is what, 2 times omega squared 21 we had times 30 like that. So this can cancel this. I have 21 times 30, and it has to be 30 joules. Okay, so 21 times 30, let's see. Alright, so it says 30 what, joules. Okay, so this is the solution to the previous question like that. Okay, so we're able to do this and do this as well. Okay, so a flat ring of inner radius 5 centimeters and outer radius 7 centimeters with inner density 5 and outer density that, find the total mass of the ring. Okay, so with this I'll state the formula, and we'll try and see if you can go through. Let's try and see. Okay, I wanted to state the formula and leave, but let's see. So these are what we've been given. We know the inner radius, outer radius, and the rest. So let's try to simplify this or write this symbolically and see. I have a ring. Okay, so we all know that a ring is circular in nature like that. Okay, and this is how rings look like. These parts are what we call the ring. Okay, so if I put a ring there, I can put it on a surface, and the shaded portion will be the ring. Okay, but when I put it on a surface, this is what they are telling us. From the surface, the center of the surface to the inner walls of the ring is having a radius of 5 centimeters, which is the same as 5 times 10 to the negative 2 meters. Okay, here is 5, and from the center up to the outer wall, okay, from here up to here, the length is what, 7 centimeters. Okay, and so the question is that they are saying that the inner density, so the density for the empty space, okay, the density for the empty space is what they call the inner density, and they are saying is 5. We don't have to talk about it. We don't need it, because that's not what you want. You want to know the total mass of the ring. So the ring is actually the shaded portion. These are the parts that we want. Okay, so now with this fair idea on it, let's try to do this. Okay, so this is how it goes about the mass. We are always saying the mass is equal to integral of lambda dA or dV or whatever you have. Okay, now since we are dealing with a circular object, okay, the mass will be equal to double integral from 0 to 2 pi. If you remember in our last discussion, we said 0 to 2 pi, then 0 to what, the radius. But here the radius is given in 2 terms. So since the center is not just here, like the center is not just here, or is here, let's say it's here, but here the middle parts are not part of what, the ring. Okay, so it means that I have to find the distance from here to here. Okay, and the distance I can't just subtract and say it's from 0 to 2, because if I subtract 5 from 7 I'll get 2, but then here this is a continuous form something, so I'll just want to calibrate from 5 to what, 7 centimeters. I hope you get it. Okay, so with this idea given, then the ring, the radius will be from 0.05 meters to 0.07 meters. Okay, now the lambda or the sigma is the density of the ring, not the density of the inner something like that. Okay, so the density of the ring was given as this. So I have 4, and we said in polar coordinate x is what r cos theta, and y is what r sine theta, then plus 6 or dx dy, and is what r dr d theta. Okay, now with this computation we can do, okay, so this is equal to integral from 0 to 2 pi, okay, integral from 0.05 to 0.07, okay, for r cos theta. Okay, so if I multiply the r here, this r through everything, I'll get what? I'll get r squared. Okay, so 4r squared cos theta. No, there is an r, then ra here. Okay, I didn't see them, forgive me. So I get 4r cubed cos theta sine theta, okay, plus 6r, then dr d theta. Okay, so now with these ideas, or with these formula given, after everything, this is what you will get. Okay, if you're able to simplify this, then the final answer will be that. Okay, now this will be equal to integral from 0 to 2 pi, okay, integral from 0 to 0.05 to 0.07, then 4r cubed cos theta, let me erase it, cos theta sine theta dr d theta, then plus integral from 0 to 2 pi, integral from 0.05 to 0.07, 6r dr d theta. You can separate it since there's a plus, okay, from basic ideas in integration. Okay, alright, so let's try and write something here. Okay, so with the first part, you can rewrite the integral as, since they are multiplying 0 to 2 pi, now take the cos, the theta aspect, cos theta sine theta, okay, then the theta, integral from 0 to 0.05 to 0.07, then 4r cubed dr. Okay, now let's check the integral for this. Okay, since they are multiplying, let's check it and see if we get 0. If we get 0, then we don't continue. Okay, with the left side of this will be equal to, now we'll let sine or cos be equal to something. Okay, so you can let sine theta be equal to u, or u be equal to that, then du will be equal to cos theta d theta. Okay, so it means the theta will be equal to what? Du over cos theta. So you just come and put it there in the first side, this side. Okay, so if you put it there, let's see, u is sine theta. Okay, so I erase it and put it back there, so I get u, then the theta is what? Du over cos theta. Okay, then this will take this. Okay, so it means that part alone, if you integrate it, kindly remember that we have u equals sine theta. Okay, if you integrate this with respect to u, we'll get something like this: half u squared from 0 to what? 2 pi. And this is u is what? Sine. So I have half u is what? Sine squared theta from 0 to 2 pi. And if you put 2 pi in this, you get 0. If you put 0 in this, you get 0. So it means the parts here, okay, this part here will give us 0. Let me use a different color for you to see. This part here will give us 0, and when you multiply to this, the whole of this will get 0. So it means the first integral is actually 0. It means the whole of this side is 0. So you will go, okay. So sometimes you don't need to do a whole big of integration. Just check and see if part will be 0. Then you don't continue and then concentrate on what you think you get an answer, okay. So it means the whole of the mass, since it's a circular this, okay, a circular something. If you remember in our first example, you solved some circular disk and you have 0 0 for the center of mass. So this is obvious. So the mass will be centered at this part. So we have integral from 0 to 2 pi, then integral from 0.05 to 0. Let me rearrange them straight away, because I can put the d theta here, and from 0.05, okay, 0.05 rather, to 0.07, okay, then 6 rdr, okay. So now this will give me theta from 0 to what? 2 pi. Then this is 6r. When I integrate 6r with respect to r, what will I get? I'll get 6r squared over 2, and that will give me 3. That will give me 3r squared from 0.05 to 0.07. Okay. Now let's erase the top and write it there. The total mass is now given as what's the simplification of this, and that will be equal to 2 pi, okay, because that's what we are having, times 3 what's into r squared, that is 0.07 squared minus 0.05 squared. Okay, since we don't have anything yet, let's continue with this, and this simplification will give us 2 pi times 3, and that will give us what? 6 pi. So they are just multiplying, so 6 pi into, then you point this in or on your calculator, okay. So you just have to point everything on your calculator, and one point in, you have 0.07 squared minus 0.05 squared, and that is giving us 0.0024, okay, times 6 pi. Okay, so I have 9/625 pi, and in decimal this will give me 0.0452 in 4 decimal place kilograms. So this is the total mass of the ring. Okay, so thank you, and don't forget to subscribe to my channel for more videos. See you next time.